Imagine a wheel rolling along a surface. If you trace the path of a point on the edge of the wheel, you get a curve called a cycloid. At first glance, a cycloid might look like a slice taken out of a circle, but it's a unique curve with interesting properties. One fascinating question is, how can we figure out the area contained between the cycloid and the ground? To understand something complicated, a great strategy is to break it down into simpler pieces. What do we know about the cycloid? First, it's created by one complete rotation of a wheel. Every full rotation moves the wheel forward by a distance equal to its circumference. Next, the width of the cycloid is the same as the wheel's circumference. The circumference of a circle is 2 times pi multiplied by the radius. Finally, the height of the cycloid equals the diameter of the wheel. Since the diameter is twice the radius, the height is 2 times the radius. Let's ignore the curving sides for a moment and approximate the cycloid by creating a triangle. We trace lines from the top center of the shape to the bottom corners. This gives us a triangle with height of 2 times the radius, base of 2 times pi the radius. To find the area of the triangle, we rearrange it into a rectangle by slicing it in half and refitting the pieces. The rectangle's height is 2 times the radius, and its width is pi times the radius. The area is 2 times the radius multiplied by pi times the radius, which equals 2 times pi multiplied by the radius squared. This gives us the central portion of the cycloid. Next, we're left with 2 curved lobes on either side of the triangle. These lobes are symmetrical, meaning they're mirror images of each other. If we fit the 2 lobes together, they form a shape resembling a pinched oval. This oval has the same height as the wheel, which is 2 times the radius, a continually changing width. Here's the key insight. If we slice the pinched oval into thin slivers and rearrange them, they fit perfectly into a circle. This means the area of the 2 lobes combined equals the area of a circle with the same radius. To find the area of the circle, imagine breaking it into wedges. Each wedge has a height equal to the radius, a width equal to 1/2 of the circumference, which is pi times the radius. The area of the rectangle, and thus the circle, is the radius multiplied by pi times the radius, which equals pi times the radius squared. Now we combine all the pieces. The triangle's area is 2 times pi times the radius squared. The lobe's area is pi times the radius squared. The total area under the cycloid is 3 times pi times the radius squared. Now you might wonder, is this formula useful? While it's rare to need this formula in everyday life, the real value lies in the process. This exercise teaches us how to take a complex problem and break it into simpler pieces, identify patterns and use basic geometry to solve challenges. Math isn't just about memorizing formulas, it's about developing problem-solving skills. These skills help us face seemingly unknowable problems, break them apart, and make them understandable. So next time you encounter something complex, remember the cycloid and how you can simplify and solve step by step.